Okay, guys, so as you can see, this is the introduction to chapter 12, congruent triangles, and we're going to start talking about the core concepts. Let's begin by, this is, I guess, a review because I think you already know how to classify triangles. We start by classifying them by sides. As you can see, this first triangle is called scaling because there are no congruent sides. All of them have different size or length. Now I want you to focus on these little marks over here that in this case are drawn for these two segments. It means that these two segments have the same length. It means they are congruent. In triangles that have at least two congruent sides, there is a name, isosceles. And as you can see in this triangle, we have the marks in all of them, in the three of them. So when a triangle has three congruent sides, it is called equilateral. Now there's also a classification by the angles. Let's just remember that an acute angle is something like this, which is an angle that is less than 90 degrees. When an angle is greater than or higher than 90 degrees, we call it obtuse angle. So if an angle has only, as you can see in this one, only acute angles, it is called an acute triangle. Now, if you see this square right here, it means that we're talking about a 90-degree angle. And a 90-degree angle or right angle happens in just one of the angles of the triangle, then we have a right triangle. There is also the possibility that there is just one, because there can only be one obtuse angle, and when that happens, we call it an obtuse triangle. If all the angles are the same, and this happens just in one situation for the equilateral triangle, those angles measure 60 degrees, then it has a special name, which is the equiangular triangle. Let's move on, talking about two different theorems that I'm going to use those theorems to solve the two exercises you see here on screen. Let's find the value of x. We're going to use two different theorems, triangle sum theorem and exterior angle theorem. In the first exercise, I want you to take a look at this first exercise where we have the interior, which is inside. The interior angles of this triangle are 85, 63, and an unknown value. There is a theorem that tells us that the sum, it means I'm going to write it in blue, the sum of 85 and 63 and x, no matter what, in two-dimensional geometry or on a plane, the sum of the three interior angles of a triangle is always going to be 180. When that happens, then you can see that we just set up an equation where we just need to solve for x to figure out the value. In this case, we just have to proceed as usual, combine like terms and reverse operations as needed. So what I'm going to do is, in this first part is going to be the combination of 85 and 63. We're going to add them and we're going to get a 148 plus x equals 180. And then we subtract 138 on both sides. All right? Which means that this is canceled out and then x is going to be 32 degrees. We're done. How did we solve it? By setting up an equation that is supported by, in this case, the triangle sum theorem. Now we're going to solve our second exercise. You can see a triangle. I'm going to circle in red some things here. You have this triangle that has this interior angle with the measure of 2x plus 6, and then there's this other angle with a measure of 36. Now I want you to notice something. This is the third interior angle, but its supplement, it means the combination of these two making up 180 degrees, the one that is outside the remaining angle, This is what we call first an exterior angle. And I want you to read this. The measure of the exterior angle, it means in this case, this exterior angle, is equal to the sum of the measures of the two non-adjacent interior angles. It means I also use the opposite angles. What does this mean? That this 4x minus 18, I'm going to write it here. 4x minus 18. The theorem tells me that this angle is the sum of the other two that are opposite to it, or non-adjacent interior angles, which means that we have 4x minus 18 is equal to 2x minus 6 plus 36. There you can see the sum of those two angles. Again, once you apply, in this case, the exterior angle theorem, we can set up an equation where we just have to solve for x as usual, simplifying or combining as needed, and then doing reverse operations. So I'm just going to complete this process by doing as usual. Probably I'm going to start by saying, okay, 4x minus 18 equals 2x plus 42. Then I'm going to eliminate one of the variables. So we have, let's continue here, 2x minus 18 equals 42 because this one's gone and this is 2x. Then we add 18 both sides. So we have 2x equals 60, and we end up dividing by 2, so x equals 30. That's all for now, guys. This is the lesson for section 12.1, and then just move on to our next